Hello everyone, welcome to Embedded System. This is another example about counters. In this example, we're going to toggle an LED connected to pin 1.0 after every 5 pulses at pin 3.4. Now, two terms to understand in this. First, it is written every 5 pulses, so we need to use mode 2, and the next is written pin 3.0, that means we need to use counter C0. So let's get going. So in that, let's start our code with a 00 and then LGM to a start. By jumping to start, we will declare port 1 as output port, as we are going to connect an LED to that particular port. Next, we'll declare pin 3.4 as input pin, as we are going to apply a wave there, and for every 5 pulses of this wave we are going to toggle the LED. Now let's set the value of a T mod. The value of T mod is set to 06H. 06H is nothing but, if we consider the bits of T mod, that is G, C/T bar, M1, M0, Z, C/T bar, M1, M0. Then we have a mode 2, that means this is 1, 0. Then we have using counter, so it is 1, and G is 0. And as we don't need counter 1 or timer 1, let's make all these pins as 0. So what we have is 06H. Then we want to define the value of TH0 and TL0. Now the value of TH0 is equal to TL0 because of mode 2, and the value of this TH0 and TL0 will be defined to 251. Now as we want the LED to be toggled after every 5 pulses, we are going to add 5, which gives us 256, which will create overflow. And at this overflow, the flag TF0 will be set. So what we do is, we'll set the values 251 into TH0 and TL0, and we'll start the counter at this point by setting bit or setting the flag TR0. Then we'll wait and keep checking whether this overflow occurs or not. The overflow will occur when we count the 5 pulses, and after 5 pulses is sensed or counted, this overflow will occur and the execution will go down. After the bit is set, TF0 is set, we clear that TF0, we clear TR0, and we complement pin 1.0 which LED is connected, and we'll repeat this process for infinite number of times. So for every 5 pulses we are going to toggle the LED. Okay, let's execute this program. To execute this program, we have added this file to our source group. Let's save this file, compile it. There it says 0 errors and 0 warnings. Then again build it. After building, let's go to a debug mode. Into debug mode, as we have connected an LED to port 1, let's open the port 1 from peripherals ports port 1 and port 3, as we have given input through port 3, and let's run this program. Once we run this program, we have to give 5 pulses to port 3, that is pin 3.4, so that LED should get toggled after every 5 pulses. So let's give the pulses. This is 0, 1, 2, 3 and 4. So we have to toggle this pulse. So 1, 2, 3, 4 and 5. So at 5th pulse we got this LED complemented. You can even check the value of TL0, which is the register's address is 8A D:0 cross 8A. So I have written this 8AH. So 8AH is having FB which is same as 8C. This is address 8A, 8B and 8C. 8C is the address of TH0. Both are having the same value as declared in the program. Now, as we increment, as we give the pulses to pin 3.4, TL0 will go on increasing, whereas the value of TH0 remains same. Right? So let's go and increment once again. 0, 1, 2, 3 and 4. So let's toggle. If you see, once it is toggled, it becomes FC. Let's toggle it again. It is FD. Let's toggle it again. FE. And now FF. Now as I toggle once more, overflow will occur and LED will go down. So here you see the LED goes down and the value of TL0 is again reinitialized to the value which is there in TH0. So in program we may avoid writing the value of TL0 here in this line number 13. So I hope this is clear to you. Thank you.